Selamat sejahtera kepada semua pelajar dengan anda. Kita mula online class kita hari ini. Okey, baik. Untuk Johor set 2, petas 2, soalan struktur ke-6 belum lagi dibincang. Okey, kita bincang soalan ini dengan okey, tengok. Raja di bawah menunjukkan eksperimen yang telah dijalankan oleh milih untuk membina persamaan ion garam tidak larut dengan menggunakan kaedah perubahan perterusan. Okay, kaedah perubahan perterusan adalah untuk membina persamaan ion. Soalnya tanya, apakah yang dimasukkan dengan garam? Okay. Garam ialah sesuatu sebatian ion yang menghasilkan ion hidrogen. Okay. Sebatian ion yang dihasilkan apabila ion hidrogen daripada asid digantikan dengan ion logam atau ion amonium. Okay, ini definisi garam. Okay, 6A2, kirakan bilangan mol 5 sien padu daripada 0.5 mol pertian padu lautan pambam 2 nitrat. Diberi M dan B, anda kiralah bilangan mol formula MB bagi 1000. Kamu dapat 0.025 mol. Okay, ada masalah? Graf 1 menunjukkan ketinggian mendakan melawan isi padu larutan kalium iodida yang telah dimasukkan. Apakah isi padu lautan kalium iodida yang diperlukan untuk bertindak balas dengan lengkap dengan larutan pambam 2 nitrat? Okay. Daripada graf, kamu carilah isi padu ini di mana ketinggian mendakan adalah mula menjadi malah. Ini merupakan isi padu kalium iodida yang anda perlu. Okay, guna untuk kira bilangan mol. Okay, di sini tindak balas adalah lengkap. Jadi 5 cm padu. Okay, letak unit. Okay. Kirakan bilangan mol lautan kalium iodida yang telah bertindak balas dengan 0.5 mol pertian padu lautan pambam 2 nitrat. Okay. MB bahagi 1000, 1 darab 5 bahagi 1000, kamu dapat bilangan mol ion iodida 0.005 mol. Okay. So, kamu bandingkan nisbah mol bagi pambam 2 dan ion iodida. Yang ini tadi kamu sudah kira ke atas. Okay. Jadi nisbah mol teringkasnya ialah 1:2. Okay. Jadi formula kimia bagi hasil terbentuk ialah PbI2. Seterusnya, B1, larutan pambam 2 nitrat bertindak balas dengan larutan natrium klorida dan larutan kalium iodida. Untuk menghasilkan pambam 2 klorida dan pambam 2 iodida. Nyatakan secara ringkas larutan pengesahan ion nitrat. Bolehkah cikgu tanya bagi pelajar yang join Google Meet hari ini, siapa yang jawab dalam BM? Semua jawab dalam bahasa Inggeris.
Ya.
Okey. Okay, you state the similarity and differences between lead to iodide and lead to chloride. Okay, the first similarity is both of them are in soluble salt. Okay, the difference is their color. Lead to iodide is yellow, whereas lead to chloride is white. Okay, that's all for a little bit discussion for the last paper. So we continue for Selangor paper 2, set 1 structured. Right. See who comment 母鸡 I hope you all please mind your words because this is recorded. Okay, Vincent? Please take note of the words that you say. Sila jaga sikap kamu, okay? Kerana pelajar nak berjaya bukan sahaja dari segi akademik. Dari segi sosial itu lagi penting. Soalan pertama. Para pelajar, okay, I hope those students who were absent for a few weeks ago, okay, could be able to come to school starting next week, okay, to take all the exercises that teacher have already distributed to the other students. So this is very important, okay. It's more convenient for you to have the hard copy than to just look at your phone, okay? It's will be more difficult for that. Okay? Selangor set 1, paper 2, question 1. The following diagram shows the apparatus set up to prepare soap in a laboratory. Okay, to prepare soap, we need palm oil, okay, reacts with concentrated sodium hydroxide solution. Excuse me. Okay, what is the reaction? State the name of reaction that's used to prepare soap. This reaction is known as saponification. Okay. And what is the function of sodium chloride in preparation soap? Sodium chloride is to precipitate the soap so that the liquid soap can become solid and you can filter it out, right? The flowing equation shows the reaction in the preparation of soap. Draw the structural formula for sodium palmitate in the space provided. Structural formula for sodium palmitate. Okay? It has a long carbon chain. This one. Okay, this part. CH3 and CH2 bracket 14. And this part, C carb double bond O and A. Okay, it is actually a salt. The byproduct is glycerol. A student wants to prepare sodium palmitate salt. What alkaline should be used? Okay, if to prepare potassium palmitate, okay, he should use KOH, concentrated potassium hydroxide solution. Okay, which the number of moles is very high. Molarity is about 5 mole per dm cube. Is very concentrated. Right. The next question. Okay, look at diagram. Table 1.1. It shows the information on the cleaning agent X and Y. Okay, cleaning action of cleaning agent X, okay, in hot water. See, the oil stain remains. That means X is soap, whereas Y is a detergent. Detergent does not form scum in hot water. So detergent is more effective. It does not form scum in hot water. Okay, this is the explanation. 2 marks. If you want to ask question, please open your microphone. Yes, switch on microphone and ask because I cannot put a chat lock here. It's full already. Okay, the window. I put 2 window already. For C, table 1.2 shows various chemical compounds that use as food additives. Okay? X, ascorbic acid, product margarine. Y, sodium benzoate, tomato sauce. Z, monosodium glutamate. So, wonder why this margarine added for, okay, antioxidant. What is the function of food additive X? Okay, here, ascorbic acid is an antioxidant. Its function is to prevent oxidation. State one side effect of monosodium glutamate on our health. Okay? The excessive consumption of MSG can cause hair fall. Hair fall and also symptoms like headache, right? Explain how sodium benzoate works as food additive. Why? Sodium benzoate is a preservative. Okay? It prevents food from spoiling by slowing down the growth of microorganisms. Question 2. Diagram 2.1 shows a pack of mothballs which is made out of naphthalene. It is usually placed in wardrobes to repel insects that can manage the fabric. Naphthalene has a strong odor. Based on the kinetic theory of matter, state the process involved and explain how the smell spreads to the surrounding. Okay, here it is a diffusion process. Diffusion is a process whereby the particles, okay, the particles for the naphthalene molecules, okay, naphthalene molecules Okay, spread or moves from region of high concentration to region of low concentration. Okay. The naphthalene molecules, the order of the naphthalene molecules always in a constant motion. So these are the 3 points. Diffusion, particles of metal are always in constant motion. And you explain the meaning of diffusion. Draw the atomic structure of carbon atom. Atomic structure, 2 marks. Okay? You need to label the nucleus of the atom and indicate how many protons and neutrons are present in the nucleus. Okay. Nuclear number is the total number of protons and neutrons in the nucleus of an atom. So 6p and 6n. Okay. 2.4 is the electron arrangement. Next, diagram 2.2 shows the heating curve of naphthalene. State the type of particle in naphthalene. It is a molecule. It's made out of the non-metal atoms, carbon and hydrogen. What is the melting point of naphthalene? From this, you can see the region B to C, whereas the temperature is constant. This is the melting point. It has a mixture of solid and liquid in region BC. 80 degrees Celsius. Why there is no change in temperature from B to C? This is because the heat absorbed is used to overcome the force of attraction between the particles to change from solid to liquid. Number 4, state the time when all the solid naphthalene melted, and the time is T2. Minute. Don't forget, always include the unit in your final answer. Number 3, diagram 3 shows the apparatus setup to determine the empirical formula of oxide T. Okay, here we have a dry cobalt chloride paper. It is used to absorb the water vapor. Diagram 3 shows the result of the experiment. Okay, what is the empirical formula for, what is the definition of empirical formula? Again, this question, let's keep on repeating, of different papers. It is a chemical formula which shows the simplest ratio of number of atoms of each element in a compound. Okay? Suppose you already, I hope you already know this one. Actually, this until now, I see the question quite easy for this set. State the change of the dry cobalt chloride paper at the end of the experiment. Okay, it will turn from blue to pink after it absorbs water. Okay, here the oxide T, which is heated strongly, it will undergo reduction to form metal T and release water. Calculate the mass of metal T and oxygen. Metal T, 20.25, you minus 12.25, and you get 8 grams Oxygen, mass of oxygen, 22.25 minus 20.25, you get 2 gram. Please inform me if there is any error in the answer scheme. Because I don't have time to check the answer scheme. I just discuss spontaneously. Empirical formula for metal oxide T, you calculate this one. After calculate this one, you find out mole ratio. Mass divided by relative atomic mass, you get the same number of moles, ratio 1:1, so is TO. For any chemical formula for ionic compound, the left side should always be metal ion. Why is hydrogen gas pass through the boiling point after heating has stopped? This is to prevent the hot metal T from reacting with oxygen gas and form T oxide again. Okay. Number 2, how to determine the reaction between metal oxide T with hydrogen that that the reaction between metal oxide T with hydrogen has completed? This is very common question. You need to repeat the process of heating, cooling, and weighing until a constant mass is obtained. D. Daniel repeats the experiment by replacing metal oxide T with zinc oxide. Explain why Daniel cannot. Sorry, I need to check the attendance first. Today, 17 students present. That means there's another 6 who didn't join this class. Daniel repeats the experiment by placing metal oxide T with zinc oxide. Explain why Daniel cannot use the same method to determine the empirical formula for zinc oxide. And here, the metal oxide T reacts with hydrogen gas, dry hydrogen gas. It asks why zinc oxide cannot be reduced by hydrogen gas. This is because zinc is more reactive. It's more reactive than hydrogen in the reactivity series. Here, this one refers to the, you need to know what is the reactant in this experiment. Don't just relate to something else like oxygen, which is not related to this experiment. Question 4. Diagram 4 shows the symbols of the atoms of element R and element S. The letters used are not the actual symbols of the element. Element R and S are placed in the same group in the periodic table of elements. State the group. Just write out the electron arrangement for each atom. This 2.1, this one 2, 8, 1. So you know it has 1 valence electron. It is at group 1. This is the reason, 1 valence electrons. Write the chemical equation for a reaction between element R and water. Lithium reacts with water. They will form lithium hydroxide and also hydrogen gas. You balance the chemical equation, and then you will get the 4 mark, 2 marks. Yeah, for this, you can substitute, instead of using the representative symbol, you can use the actual symbol as well, Li. B2, between the elements R and S, which is more reactive when reacts with water? R and S. Of course, okay? When going down group 1, the reactivity of the elements increases. So S is more reactive than R. Why? 3 marks. The first point, you compare the size. The atomic size of S is bigger than R. Then you compare the force of attraction. The force of attraction between the nucleus and the valence electrons of atom S is weaker, because the distance between the nucleus and the valence electron becomes further already. So force of attraction between the nucleus and the valence electron in atom S is weaker. So atom S is easier to release its valence electron. C, element S reacts with oxygen gas to form a white solid. Yeah, it will form sodium oxide. Draw the electron arrangement for S2O. You need to know, eh? The atom will form white ion, and then you draw like this. Number of shells and electron, correct, you get 1 mark, and the correct charges. Better that you draw another one, sodium ion at the right. So it's you can see the opposite charges, the electrostatic force, positive, negative, positive. Okay. Number 5. Diagram 5 shows the setup apparatus to investigate redox reaction. Show the direction of the electron flow in diagram 5. Electron flow. It flows from where oxidation occurs to reduction. That means from the reducing agent to oxidizing agent. When you answer redox question, you get the question, you just write a half equation at the diagram. Easier, okay? Release of electron is cross oxidation. And it also involves the increase in oxidation number. This one, manganate ion form manganese 2 ion plus 4 moles of water. So here we put 8 moles of hydrogen ion, and the rest is electron. Total charge should be positive 2 for each side. 7. So this is 5. Okay, this is a reduction half equation. So the electron moves from electrode T to electrode Q. The function of sulfuric acid is to allow the movement of ions. And to complete the circuit. Okay, two functions. The most important function is to allow the movement of ions. When the movement of ions can move freely through the different solution, different agents, so the electrical circuit can be completed. Referring to the reaction that takes place at electrode P, write the half equation. Done already, this one. Describe a chemical test to determine the product form. How could we confirm the presence of iodine as the final product? Okay, you can use trichloroethane. Okay, you can put trichloroethane in the mixture, or you can use the iodine water. Sorry, such solution. Okay, you use dropper, you add a few drops of such solution in this arm, at the left arm. You can see the solution change color from brown to dark blue. Brown to dark blue. Brown color is actually the color of iodine solution. When you change to dark blue, it means iodine is present. Okay, 2 marks. Procedure and also followed by observation. You can use 111 trichloroethane. How to write? Okay. You can use a dropper. Use dropper. Take 2 cm cube of solution. Okay, at electrode P, and transfer it to a test tube. Add 2 cm cube of 111 trichloroethane to the mixture. Shake the mixture. Okay. The bottom layer, which is the layer of layer of 111 trichloroethane, shows purple color. So iodine is present. This is another alternative for this alternative answer for this question. What is the change in oxidation number for iodine? Yeah, it changed from -1 to 0. Referring to the reaction that takes place at electrode Q, what is the color change of acidified potassium manganate 7 solution? It will change from purple to colorless. And what is the function? The function is it acts as agent, oxidizing agent. Okay, the half equation has already been discussed just now. The change in oxidation number for manganese is from +7 to +2. Okay. Suggest one substance that can be used to replace acidified potassium manganate 7 solution in order to get the same product at electrode P. The same product. means you use another oxidizing agent. You can use chlorine water or acidified potassium dichromate 6 solution. Bromine water also can. Okay, bromine water is a weaker oxidizing agent if compared with chlorine water. Question 6. Diagram 6 shows the apparatus set up to determine the heat of precipitation for lead-2 sulfate. You see the temperature change. The highest temperature, okay, the temperature increases. So it shows this reaction is an exothermic reaction. Okay, the initial temperature for both solutions are different, and before they are mixed together. So you need to you need to use the average temperature, average initial temperature to calculate. She's 27.5. What is meant by heat of precipitation in this experiment? Okay? Heat of precipitation is the heat change. Heat change, sometimes it's not heat release, no, but here is heat release. Okay? Sometimes it's heat absorbed. Heat of precipitation can be either exothermic or endothermic. So take note. It's a heat change when 1 mole of precipitate is formed from the reaction between lead-2 ion and sulfate ion. Okay, because the question asks, in this experiment, so your answer should be specific according to the reacting ions in this experiment. Okay, be specific. Observation. Okay, you can see white precipitate is formed, lead-2 sulfate. Ionic equation, okay, just involve lead-2 ion reacts with sulfate ion form PbSO4. Calculate the heat change in the experiment. Heat change, you use the formula H equals to mc theta. Okay. Theta is 33.5 minus 27.5. 6. M is the mass, okay, which also same as the volume of both solution times the constant 4.2. Okay, so you get 2,520 joule. Calculate the heat of precipitation of lead-2 sulfate. Okay, this one 2520 joule convert to kilojoule, 2.52 divided by number of moles for lead-2 ion or sulfate ion. Okay, look at here. Lead-2 ion and sulfate ion have the same number of moles. Okay, same number of moles. So you can calculate either this or this, so same 0.05. So 2.52 divided by 0.05. Don't forget to put the sign negative sign. Okay, indicates this is an exothermic reaction. And also the unit kilojoule per mole. Okay, draw the energy level diagram for this reaction. Energy level diagram. Exothermic, exit means keluar bangunan, turun tangga. Okay, like this. Write the ionic equation. on the lines. And the middle, write the thermochemical equation. Okay, the heat of precipitation. This one, don't forget, label is important. Energy. Okay, F1. The experiment is repeated by using 50 cm cube or 1 mole per dm cube lead-2 nitrate solution and 50 cm cube or 1 mole per dm cube potassium sulfate solution. Just now, we use sodium sulfate, okay, and then it used potassium sulfate to replace it. Same or not? Okay, they are actually same because here sodium ion and potassium ion both are not involved in the formation of precipitate. So the heat change is same. It is still 6 degrees Celsius. Okay. Okay. Explain your answer. The formation of precipitate. The formation of lead-2 sulfate precipitate only involves lead-2 ions and sulfate ions only. Yeah. So this structure question very common. Not necessarily need to refer to answer scheme. Can have already. Yeah. We move to the next paper. Paper 3. Johor one haven't discussed, right? Discuss Johor first. I only discuss Selangor set 2 paper, Selangor set 1 paper 3. Okay. "17 students, another 6 where?" Later I'll find out. MPSM Johor question actually 4 past paper done by the chemistry panel in Johor Bahru. Okay. This experiment is to determine the effect of temperature to the rate of reaction. 2 grams of zinc powder is added to 100 cm cube of hydrochloric acid of 0.2 mole per dm cube at room temperature in a conical flask. Okay. Zinc react with hydrochloric acid will form gas. By using this water displacement reaction in burette, you can record the volume of hydrogen gas which is released at every 30-second intervals. Okay. Until it collect 50 cm cube. The experiment is repeated by using different temperature of hydrochloric acid. The acid is heated at 50, 35, 40, 45, 50 degrees Celsius as shown in diagram 2. And the time to collect 50 cm of gas are recorded. Initially, the person conducts the experiment at room temperature. After that, increase the temperature. Okay, record the time taken. Okay, look at this stopwatch. The smallest scale is, see here, 1 round is second, 60 seconds. The smallest scale is 1 second. So for reading, you need to put 1 decimal place. Okay? So this one is 58 in the middle, right? So 58.5 second. Experiment 2, 43.0 second. Experiment 3, 32.5 second. Experiment 4, 19.0 seconds. Experiment 5, 8.0 seconds. Yeah. 1 decimal place all correct, you get 3 marks. Construct a table to record the time taken to collect 50 cm of hydrogen gas in this experiment. Time taken. Same, very easy it is. Record like this, 3 columns. Put the unit at the title. Okay, MV, RV, and CV. MV, you manipulate the temperature. Responding is the rate of reaction, or the time taken to collect 50 cm³ of hydrogen gas. Responding variable has 2 types. One is implicit, one is explicit. Implicit means tersirat lah. Yang tersirat dia boleh, implicit one you can use the explicit one to observe. Okay? Constant, this one is fixed. Volume and concentration of hydrochloric acid. Okay? Size of zinc also fixed. Hypothesis. Hypothesis is a statement how the manipulated variable affect the responding variable. When the temperature increase, when the temperature of hydrochloric acid increases, the rate of reaction is higher. Or when the temperature of acid increases, the time taken to collect hydrogen gas is shorter. Normally, for hypothesis, the responding variable is the implicit one. Okay, you use rate of reaction. Okay, untuk hipotesis, pemboleh ubah bergerak balas adalah yang tersirat. Biasanya. Inference, mengapa? Okay, observe. Okay, observation. Observation. The time taken, observation adalah pemboleh ubah bergerak balas yang tersurat lah. Okay, refers to the time taken to collect 50 cm3 of hydrogen gas. Okay. But here you write what? Gas bubbles. Gas bubbles. So simple. Okay, colors gas bubbles are released. Observation, hydrogen gas is produced. G. State the relationship between the temperature of hydrochloric acid with the time taken to collect 50 cm3 of hydrogen gas. So just now for pemerhatian, for observation, just very straightforward. Simple. Don't think too complicated. Like what I did just now. Because in a G, only it asks, okay, to state the relationship. When the temperature of hydrochloric acid increases, the time taken to collect 50 cm3 of hydrogen gas decreases. State the optional definition for the higher rate aeration in this experiment. Operational definition. You need to know there are 2 points you need to answer. What is observed and what is done. The higher rate of reaction can be observed by what? The higher rate of reaction is the shorter time taken to collect 50 cm3 of hydrogen gas when zinc is added to hydrochloric acid. At different temperature. Tambah ini. So like what if I stop at 2 hydrochloric acid, I only get 2 marks. So if you write this, you get the 4 marks, 3 marks. So I highlight this one, okay? Normally we may miss this point. To answer definition, operational definition, you can either start with what is done, followed by what is observed, okay, or vice versa. Predict the time taken to collect 50 cm3 of hydrogen gas if the temperature of acid is 50 degrees Celsius. That means higher than this. This one takes 8 seconds to complete. So for this, the answer should be less than 8 seconds. Your answer, you cannot write less than 8 seconds. Right? This is wrong. You need to give a particular temperature. Okay, within this range, either 3 degrees Celsius, 3 seconds, 4, 5, or 6 seconds. Your answer cannot be in a range. Okay? Must be a particular answer, 3 seconds, 6 seconds, okay? Classify the metal that can react with hydrochloric acid to produce constant hydrogen gas for this experiment and metals that cannot. Okay, here the reaction between metal and acid. Okay, the metal is the metal that is more reactive than hydrogen ion in the reactivity series. So which metal is located above hydrogen in the reactivity series? Then they can react only, then they can react with hydrogen gas. Sorry, react with acid. So copper cannot, copper cannot react with the acid. Magnesium, zinc can. Lead can, but very slow, extremely slow. Consider cannot here. Argentum, silver cannot because it is located below hydrogen in the reactivity series. There are only two reactive metals here, magnesium and zinc. Question 2. A conversation between two students is shown in diagram 3 below. They are discussing about the chemical cells that are done in lab. Okay, this girl said, magnesium with copper in copper 2 sulfate solution gives 2.2 volt. And let's try again with zinc, stannum, and lead. It means they repeat the experiment by replacing magnesium with zinc, stannum, and lead. The solution is still the same. And here, they actually use different, they use different pairs of metals, different pairs of metals. Electrode copper, still the same, and the electrolyte also same. Referring to the diagram, plan a laboratory experiment to investigate the effect of position metals in the electrochemical series to the voltage produced. Problem statement. Okay, problem statement is a question to ask how the manipulated variable, how does the manipulated variable affect the responding variable? So you need to do B first. Always start with identify the variables. Okay. From this diagram 3, you manipulate the pairs of metals. Responding variable, voltage produced. Constant, copper, type of electrolyte. Responding variable, here say product at negative terminal. Do you agree with this answer scheme? This one. Hi. Could anyone respond about this?
No.
I don't agree. Okay. So you agree with voltage produced as RV? Agree?
Yes.
Huh? Okay. Okay. Problem statement. How does different pairs of metals affect the voltage produced in the chemical cell? Or how does the how does the position of metals in the electrochemical series affect the voltage produced? Position. Okay, or how does the distance between two metals in the electrochemical series affect the voltage produced? I think this one is the most suitable. Okay. Okay. How does different pair of metals affect the voltage produced? We stick to this. Don't just keep changing. Hypothesis. The further the distance between two metals in the electrochemical series, the higher the voltage produced. Okay, same like the answer scheme. List of metals, sorry, list of materials and apparatus. Materials, copper 2 sulfate solution, okay. Magnesium strip, copper strip, zinc strip, stannum strip, and lead strip. Jalur logam berbeza-beza. Atau kepingan logam pun boleh. Kepingan zinc, kepingan bambum. Kena bika lah. Bika. Connecting wire and crocodile clips. And this one. V. Suddenly forgot his name. Wattmeter. Okay. You need sandpaper also. Battery. If you suddenly just can you skate okay, if you worried lah, you just draw you imagine or you draw the chemical cell, then you won't miss any apparatus or material. You draw the diagram first, even though the diagram, label diagram, okay, doesn't give any marks, okay? But actually, it helps, because from the diagram, if you label it correctly, actually can help you, okay? Marks can be taken from there also, from the label diagram. Mention the number, the molarity. Okay, for any solution, salt solution or acid solution, acid or alkali, the molarity should be in the range from 0.1 to 2 mole per dm cube. procedure. You cannot write just prepare the setup apparatus as in the diagram above. This sentence has no marks. Okay, you need to explain in sentences in details. Okay, first, actually need to draw first. Only okay. Like this. Copper sulfate solution. Yes. Okay, so you know, first you can clean the metal. Okay? Either you clean the metal first, or you pour the solution in the beaker. And pour. Here we use 0.5 mole per dnq. We can use 1 mole per dnq. Pour 0.5 dnq of copper 2 sulfate solution in a beaker until half full. Half full. Number 2, clean the magnesium ribbon with sandpaper and connect the magnesium ribbon and copper strip to the white battery. Actually should be 1 meter. So just now actually we don't need battery. Right, you don't need it. This is a chemical cell. Dip the magnesium and copper into copper 2 sulfate solution. Okay. After connect it with connecting wires, only you dip. Determine the terminal. Determine the negative terminal. Okay, the voltmeter, if the voltmeter 0 is here, if the voltmeter needle deflect to the wrong side, for example, becomes negative, that means you already connect the electrode wrongly to the voltmeter. Okay, you need to switch the terminal. Suppose this is deflects to the right, mean higher than 0. Determine the negative terminal, record the voltmeter reading. Repeat the experiment by using zinc, tin, and lead strips to replace magnesium. So remember, in your procedure, generally, there are a few points you need to include. First, your procedure should mention about the constant variable. So number 1, get 1 mark. 3, this one is a manipulated variable. Different pairs of metals. 1 mark. The third mark is you observe and record the responding variable. Perhatikan. Observe first only record. Please add this. This the responding reports. So 3 marks. In your procedure, I have to mention NV, RV, and CV. The rest is how you conduct the experiment. 2, 4, 5. And the last, repeat. Forgot one. Repeat. Like this is this paper. Finally, 1 mark for tabulation of data. You don't have to fill in the readings or the observation. Just leave it blank. Okay, you just need to write the manipulated variable and the responding variable. What you have to record in this experiment. Okay? 3 marks. Okay, so we have done with this set of paper, done with the discussion. Selangor paper 2. Okay, Selangor set 1 paper 3. Table 1.1 shows the data collected by a student to determine the relationship between the concentration of hydrochloric acid with pH value. 250 cm³ or 1 mole per dm³ standard solution is prepared. The acid solution is then diluted to produce 4 solutions with different concentrations. pH value for each solution is determined by using pH meter. Excuse me, drink first. Okay, this one is standard solution. Then it do dilution. From here, from this table, it already indicates what is the manipulated variable and the responding variable. Cannot highlight something. Based on data in table 1.1, complete table 1.2. Okay, manipulated variable is the concentration of hydrochloric acid. And what is the action? What is the action taken to manipulate the manipulated variable? You dilute, okay? Dilute or use different concentration of hydrochloric acid. Or dilute the standard solution of hydrochloric acid to lower concentrations or to different lower concentrations. Responding variable. Responding variable here, pH value. Okay. How could you determine the pH value? Okay. You use pH meter to measure the pH value of the acid solution. Okay. From the reading of pH meter, okay, you can get the pH value. Reading of pH meter. Constant variable. And here you use the same type of acid. Types of acid. Use the same type of acid. Hypothesis. When the concentration of acid decreases, look at the table 1.1. When the concentration of acid decreases, the pH value of the acid increases. Predict the concentration of if you use higher, lower also can. Predict the concentration of hydrochloric acid solution if the pH value is 6.3. That means the concentration is very diluted. 0.00001. Okay, the concentration of the acid should be lower than the fifth one. One, two, three, four, five. Twice lower than. There are 5 0 here, 0.000001. Because this one is 1, here 2, 3, 4, then 5. Actually, pH can be calculated. It's in the syllabus of KSSM. Is okay, like this. pH equals to negative log concentration of hydrogen ion. This one is the concentration of the acid. Okay, you can calculate and you can estimate this. Okay. So given pH already, you need to find out this one is you use calculation math. Calculate the volume of the standard solution needed to prepare 250 cm³ of 0.01 mol per dm³ of hydrochloric acid solution. Moment. Okay. This one you use formula N1V1 equal N2V2 for dilution. Prepare 250 cm³ of 0.001 means this one is a V2, M2 and V2. Volume of standard solution. So 1 times V1. So you get V1. Okay, 2.5 cm³. Means you use pipette out, pipette 2.5 cm³ of the standard solution and you dilute it in a volumetric flask to 250 cm³. E. A student then carried out an experiment to determine the endpoint for neutralization reaction between the standard solution of hydrochloric acid and sodium hydroxide solution. 2 drops of phenolphthalein indicator were added to sodium hydroxide solution in a conical flask. The hydrochloric acid from the burette is added carefully into the conical flask until the mixture changes in color. The titration is repeated 3 times using the same volume and concentration of sodium hydroxide solution. Diagram 1 on page 6 shows the initial and final burette readings for the experiment. Record all the burette reading for the experiment in diagram 1. Okay, burette reading this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one is 2.8. Okay, so burette, the smallest still is 1 decimal place, right? So for accuracy, you need to add 1 more decimal place, so become 2 decimal places. 2.80. Sorry, it's not 2.8. 1.2. Okay, 1.2. Okay, tengok dari atas sini. 1.20 cm³. Final burette reading 25.30. This one 2.90, this one 27.20. This one 0.50. 0.55. 24.60. Construct a table to record the initial burette readings, final burette readings, and the volume of hydrochloric acid used in the experiment. Okay, add 1 more row. Use the larger value minus the smaller value. Final burette reading minus initial burette reading, you get the volume of hydrochloric acid used in that titration. Don't forget and remember, always include the unit in the title. State the color change of phenolphthalein indicator in the declaration. Okay? Phenolphthalein indicator is dropped into the sodium hydroxide solution, so the color of the solution becomes pink. At the end point, it turns to colorless. So pink to colorless. Based on the experiment, give the operational definition for the acid in this experiment of titration. Okay? For social question in paper 3, it will definitely ask about operational definition. Okay? Again, you need to answer 2 points. What to do, or what is done, and what is observed. Okay, if you start with what is done, apabila. What is done? For the AC in this experiment titration. Okay, what is observed is this. You can observe the color change of phenolphthalein from pink to colorless. Okay. Operation definition. Acid is a chemical substance that can change the color of the phenolphthalein, the color of the phenolphthalein indicator from pink to colorless at the end point. When reacts with sodium hydroxide solution. So now I want to confirm the answer. Okay. Reacts with, so you say neutralized. Okay. Acid is a chemical substance that causes phenolphthalein to change color from pink to colorless at the end point when it is added or when it reacts with sodium hydroxide solution. Okay, this reaction is neutralization when reacts with already can be accepted. Yeah, remember, no matter what type of definition, operation definition the question asks, remember, just answer 2 points. What is done, what is observed. If the hydrochloric acid is replaced with sulfuric acid of the same concentration, okay, means the second time it repeats the experiment by using diprotic acid. It is found that the volume of sulfuric acid used in the titration is half the volume of hydrochloric acid. Explain why. 3 marks. Okay. Sulfuric acid is a diprotic acid. The concentration of hydrogen ions in sulfuric acid is twice the concentration of hydrogen ions in hydrochloric acid. So you get 3 marks. Okay? You need to explain both. Just now I only talk about sulfuric acid. So you need to talk about both. Hydrochloric acid is a monoprotic acid. Okay? For the first sentence. Mention both. The second one, you compare the concentration of hydrogen ions. Okay? In the ionization for sulfuric acid. Below are some examples of acids: hydrochloric acid, sulfuric acid, nitric acid, acetic acid. Acetic acid is a common name for ethanoic acid. CH3, COH. So vinegar. It's vinegar. Monoprotic, diprotic. So diprotic, there's only one. The rest are monoprotic. Okay. Sulfuric acid. S2, SO4. Ionization of 1 mole of sulfuric acid will produce 2 moles of hydrogen ions. Is the meaning of diprotic acid. Question 2. Diagram 2 shows the examples of disposal plastic cups used around the world. Disposal plastic cups are often made from polypropylene plastic, which is a type of polymer. Polypropylene. Okay, some type of plastic can withstand temperature of 100 degrees Celsius, but some plastic can melt in hot water. You are given 2 types of plastic cups made from plastic A and plastic B. Using suitable substance and apparatus, plan 1 laboratory experiment to compare the heat resistance of plastics in hot water. Is this in your syllabus, about plastic? Okay. Which chapter you learn about plastics? May I know which chapter? About polymer, right? Okay, I think it's Form 4 last chapter. Just a minor subtopic, okay? So first of all, you identify all the variables in this experiment. Okay, types of plastic is the manipulated variable. The responding variable is the heat resistance of plastic. Or the condition of plastic. Okay, keadaan plastik selepas letak dalam lautan dalam air panas. Condition of plastic after being put into hot water. Tulis ini ya. Ini tak nak potong. Ketahanan plastik terhadap haba pun boleh. Problem statement. Problem statement, other than use how, you can use is. That means you directly make an assumption. Is plastic A, okay, is plastic A more heat resistant compared with plastic B when put in hot water? Or ini ya, okay. Or which plastic will melt when put in hot water? Or plastic A or plastic B will melt when put in hot water? Soalan 1 dan 2 adalah sama. Actually, same. I think the first and the third one better. The second question is a bit not so smooth when I read. Next. Hypothesis. This question. Okay, because we don't know which plastic is thermoplastic, which one is thermoset plastic. Okay. So the answer could be vice versa. That means plastic B does not melt when put in hot water, while plastic A melts. Okay, or the other way. List of materials and apparatus. Okay, you need plastic cup A and plastic cup B, hot water. Apparatus. Yeah, are those apparatus you use to heat up the water until it boils? Beaker, 250 cubic beaker, Bunsen burner, wire gauze, tripod stand, tongs, scissors. What's the use of scissors here? I think this type of question will not come out in paper 3. Okay. Procedure. Okay. Used to cut the plastic. Now I understand. Cut a piece of plastic A. Okay, into the length of 5 to 10 cm cube. 2. Okay, fill the beaker with water until half full. Heat the water using Bunsen burner until it boils. Actually, no need to mention Bunsen burner one. Heat the water until it boils. Put plastic A into boiling water for 10 minutes. 10 to 15 minutes. Using tongs, okay, the metal pengapit. Using tongs, remove the plastic from the boiling water. Record the condition of plastic. Don't write observation. Okay. After taken out, from boiling water. Tabulation of data. The manipulated variable is types of plastic. Responding variable is the condition of plastic after taken out from boiling water. Okay. Because for science, for general science, for observation, they need to state clearly. But for chemistry, I think it's better that you write clearly like this. Okay, but according to this answer scheme, it said observation 2 marks, because 2 marks only, I think no problem. Okay, you can just write this. So that's all. Now, Selangor set 2. Selangor set 2, paper 1, please do yourself and check the answer. Okay, it's already been uploaded in the group. Okay, are you following? Because I talk too much, so I have the gases in my stomach already. Let me take the attendance. Selangor set 2. Selangor set 2, paper 3. The design question 1. I want to ask, Jie. So, who are the students that still cannot attend school? They still cannot come to school next week? Please PM me. I hope you could come. Don't be too worried. You pray, okay? You pray and you will have peace, and then you can come. For Selangor set 1 and 2, both have the same specification item. So the type of question and the topic are actually same. Okay. So again, the student carried out an experiment to determine endpoint for titration 25 cm³ of sodium hydroxide solution with 1 mole per dm³ of hydrochloric acid. Phenolphthalein is used as a base indicator. So this one you do record, write down the initial and final reading in 2 decimal places. Don't forget to include the unit cm³. Okay. This one also same. You construct a table, record the initial bill reading, final bill reading, and the volume of acid used, but use the final bill reading minus the initial bill reading. Include the unit in the title for the reading. Calculate the average volume of hydrochloric acid used in the experiment. So total up the volume of hydrochloric acid used in 3 experiments divided by 3. You get the average. So this one I discuss very fast. You need to do it yourself later. If the experiment is repeated by replacing 1 mole per dm³ of hydrochloric acid with 1 mole per dm³ sulfuric acid, predict the volume of sulfuric acid used. Okay, the volume of sulfuric acid used should be half the volume of monoprotic acid. So in 2 decimal places as well. For example, if 12.50 cm³ like that. Okay? If this one is 25. Anyway, I need to calculate because I haven't checked the answer. Acids can be classified into strong and weak acid. Okay, there are how phosphoric acid is strong or weak? Hello? Anyone can respond? Yeah, I'm worried you doze off, you sleep already. No. So someone please respond. Hello?
你问什么
Phosphoric acid strong or weak?
weak acid weak
We are, yeah. Okay. 会太快吗？那个is it too fast? Are you able to follow? Hello?
yeah
Are you answering the question at the same time or just listen only? Are you listening and also writing?
Yeah.
yes
Okay, that's good. I want to double check the answer. Yeah. Phosphoric acid is a weak acid. Determine the concentration of sodium hydroxide solution used for titration. Okay. The MP can be calculated by using formula. And MABA divided by MB VB equals to A over B. So this one is monoprotic acid. The ratio for acid to alkaline is 1 to 1. Therefore, it only produces 1 mole of water. So 1 to 1. You substitute the value MA, VA. VA is the average volume for hydrochloric acid that you have calculated in the previous section. MA is given in the question, which is 1 mole per dm³. Calculate MB, VB 20, is it 25? Yes. So, final answer must have unit. What is the operational definition for acid in this experiment of titration? Then you need to write notes here. What is done? Even though you know, but I think it's better you write so it can guide your thought. What is observed? Okay. Is it same as set 1 answer? Let's see. Acid is a, I think same. Okay, here the observation are same. At the end point, the color of phenolphthalein will change from pink to colorless. This is what you can observe. And what is done is, what are the reactions when the acid is titrated or is neutralized with sodium hydroxide solution? When talk too much, I tend to have like flatulence gases come up. Acid is a chemical substance, okay, that is a chemical substance which can be neutralized or which can react with sodium hydroxide solution and cause the color change of phenolphthalein from pink to colorless. Okay, that's the idea. Sama dengan tadi ya. Acid is a chemical substance when added to neutralize sodium hydroxide solution. Try to write it yourself, okay? Because this sentence is a bit, it's not correct grammatically. You try to make it a correct sentence, okay? But the idea is there, okay? Grammatical mistake will not be penalized, okay? Don't worry. As long as you have the idea, you have the point, you get marks. Acid is a chemical substance that reacts with sodium hydroxide solution and will cause phenolphthalein to change from pink to colorless at the end point. Tambah ini ya, at this. When reacts with, when neutralizes pun boleh. Meneutralkan dalam bahasa Melayu. Betina pastengan. I hope you know, understand what has been discussed today during this online tutorial class. Okay, thank you PECUTAN AKHIR KIMIA. Series 1. So, saya nak tanya, I want to ask your opinion. Because next week, next Wednesday, is the start of Chinese New Year holiday. School holiday. Okay, so we don't have class on Friday. Can we change the date to the other day? Which day you want? You want during school day on Saturday, Monday, or Tuesday after school, or Wednesday or Thursday morning? Because I cannot cross border, I cannot go back hometown. I'm still in JB. How about you all? Are you in JB next week during school holiday? Okay, you think first, and we want all of you to have a common decision. Okay, which day that we could have Google Meet again next week? I think need to have 2 classes next week, 2 online classes. Take other teachers period. How can? Okay, because all are exam subjects. Tak boleh lah, betul Izu kata. Okay, cannot. So you have to spare time. Okay, luangkan masa. Okay, so next week, fix 2 days. Wednesday and Thursday morning, okay? Do you have tuition on Wednesday and Thursday morning? Hello? No, no tuition. 有啊
No.
Have tuition or not Wednesday, Thursday morning? From what time? 9 to 11. Have you woke up at 9? No. Siapa kata no? Ada orang kata okay 10. Okay. 10 to 12 can? Okay. 10 to 12 fixed already. Majority said okay. Good. So we fix Wednesday and Thursday next week. We have our online chemistry tutorials. So see you guys. And next Sunday at school, I hope all of you can come to school. Okay, don't worry. Send group the time. Okay, no problem. I'll update the time at the group because the other classmates who haven't joined. Okay, so I need to notify them as well. Thank you for your participation in today's Google Meet. I hope you can continue your studies at home. So just manage your time well, between your rest time and also study times. Most importantly, I hope your attendance is very important. Okay, we'll see you next week during class. Okay, at school.
Bye bye, teacher. Thank you.
Welcome. Thanks. See you. Okay. All right. Welcome. Thank you. Teacher loves you.